Hello, all you maths nerds. Today I'm going to take a look at one of Matt Parker's maths puzzles. And yes, I do believe that pause is part of the correct pronunciation of the show. This week's puzzle is the $1 million bank balance puzzle. So the way this works is on day one, you make a deposit, and let's just use pounds because the symbol is more fun to draw. Let's say you make a deposit of £1. So your balance, of course, is £1. On day two, let's say you make a deposit of £2. So now your balance, no surprise here, is £3. But here's where the fun happens. On day three, the bank is going to take your current balance and add to it the previous balance, and that will be your new balance. So you'll have £4. Similarly, on day 4, the bank will add £3 to £4, and you'll end up with £7. Now, the challenge is to get all the way to £1 million exactly. You have to land exactly on £1 million, no more, no less. And, by the way, these are integers only. So, let's take a look at this. First thing you may notice is, hang on a second, the bank is adding the previous two balances to get the new balance. Isn't that just Fibonacci? So let's go to our good friend, the golden ratio. And I think that's all the digits we're going to need. And let's try to calculate this backwards. Let's start on day n. So our balance on day n is equal to 1 million. We know that in the Fibonacci series, adjacent values converge on the golden ratio. So your balance on day n minus 1 is going to be $618,034. From here we can just continue to work backwards. The balance on any day n is equal to the balance of day n minus 1 plus the balance of day n minus 2. We rewrite the formula so that our balance on day n minus 2 is equal to balance on day n minus the balance on day n minus 1. Now we have an easy formula to calculate each successive day going backwards, starting from £1 million, then going to £618,034, and you just carry on. And you keep on following this pattern until you can't reduce the numbers any further. I've saved you all the tedious boredom of all the working out, but let's take a look at what happens here at day n minus 19. Our numbers have switched direction. They've been getting smaller, and suddenly it's gone up again. What this means is if on day 1 we deposit $144, then on day 2 we deposit $154, bringing our balance up to $298, then that means on day 3 the bank will sum our previous two balances to get $442, then $740, all the way up to $1 million on day 19. So you would think 19 would be the solution. However, I remember Matt distinctly saying that the bank doesn't put any rules on how you do the working out. So what that means is we can just carry on with our formula, taking the last day and subtracting it from the one before that. So on day n minus 20, we end up with negative 10. Well, what does that mean? Well, certainly a negative number is just fine. A negative deposit is just a withdrawal. So if we carry on one more step, we take 154, subtract negative 10, and we end up with 164. So now if we shift our days down, on day 1, we withdraw $10 from the bank, giving us a balance of negative $10, which is certainly fine. Some banks allow you to overdraft and go into the negative. And then on day 2, we add $164, giving us a balance of $154. On the following day, the bank sums our last two balances, 154 and negative 10, and we end up with a balance of 144. Following that, the bank sums these two and gets 298, and so on, back up to 1 million. So in effect, what we've done is we have shifted everything down 2 days, making this take 21 days instead of 19 days to reach $1 million. We've added an extra 2 days. That's great. The bank didn't say whoever uses the least starting deposits, whoever takes the longest to reach $1 million, is the winner. So what's to say we can't carry this on further? We take negative 10, subtract 164, and we get negative $174. What this means is, on day 1, we deposit $164. On day 2, we withdraw $174, giving us a balance of negative $10. Everything is shifted back by another day, and now it takes 22 days to reach $1 million. So now, on day 1, we withdraw $174, and then on day 2, we add $338, giving us a balance of $164. And we've given ourselves an extra day to reach $1 million. Now you can see this carries on for as long as you like. In essence, it can take arbitrarily long to reach $1 million. It just depends on how much starting capital you have. The more money you can put in, or the more you can overdraft, the longer you can take to reach $1 million. So there are infinitely many answers to this, because you could just carry on this process further and further, alternating between positive and negative balances, and it will simply extend the time it takes to reach $1 million. So the answer is, whoever has the most money, or whoever is allowed to overdraft the most, is the winner of the $1 million. It can take arbitrarily long to reach the target. Thank you for watching. I'm the Mathological Nerd. Please subscribe and hit the bell and all of that good stuff, and I will see you on the next one.